Okay, so yeah, I would like to spend some time in the beginning just talking about the concepts of APIs in general. Um, some of you might find it boring, so if I start seeing people fall asleep, I'll try to scoot it along. I think some background might be helpful to some. I mean, I kind of like history, but I think part of that is because I'm so old that I was part of that history. But you know, for you, I think maybe it'll give you some context to what we're talking about, and then the latter part, which hopefully will be more of the time that we'll spend, we'll actually try to implement a API. Um, I'm gonna kind of leave it open ended because I didn't want to make it too easy or too hard. So it's gonna be like a collaborative effort where we kind of work together to kind of create this thing. And whether you want to include middleware, whether you want to do routing, well, whatever, we can all kind of talk about that and implement that as we see fit. To. So I want you guys to learn out of this, not just watch me do stuff. So it's kind of the aim. So those are the two parts. So let's start with uh, some of the ideas. So API starts with the concept of an application program. An application program, most simply, is just something that helps you do something with software. Word processor, media player, accounting software, blah, blah, blah. So we're good with that terminology. Application program. Interface. Interface is kind of an interesting word because in interface, in the most general sense, we talk about, let's say, user interfaces. And it's something that we as humans kind of have been adapted to do, is to kind of abstract or simplify things that we interact with on a common basis because we can only handle so much computation in our brains. Hey, John. And so, one good example of that, and what example I have here is the car. The car is a quintessential interface. The car on the right, before I have to ask you, Beach, because I'm sure you've been in a car at some point in the last 20 years, how would you go forward in a car? How do you tell the car to go forward? Automobile, go forward. Okay, put your foot on the right pedal, right? How about Clements? Have you driven it? Charlie, have you driven a car before? Nope. But do you know how to make the car turn left? How do you make the car turn left? You turn the wheel left. Yeah, it's very, it's somewhat intuitive. How about how do you get out of park, Michael? How do you get out of park? But where on the interface? Okay, so you're using your hand to kind of signal that maybe that this little thing sticking up helps you do the same thing, right? Now, this is one that is somewhat modern, probably within the last 5 years. Whereas on the one on the right is maybe a little older, maybe 30, 40 years ago. But the interface is the same. There's still a pedal to go. There's still a wheel to turn. And there's still something to get out of park. So this idea that underneath this car, I'm not sure how many of you guys actually have done any kind of automotive repair or know how the engine works, how brakes work, how brake line, hydraulics work. How, is the steering wheel attached to a rack and pinion system? Is it added to a pitman arm? Like some of this probably stuff doesn't even mean anything to you, right? But you can still operate a car. So there's a lot of stuff happening behind this black box, but the only thing that we see to interact with this car is this interface, the wheel, the pedals, this little lever to take it in and out of park. Okay, so that's kind of the idea that we also transfer to software, is that there's going to be a lot of stuff behind the software that we don't know, but it's okay. We provided input, it gives us output, right? And that's kind of our relationship to this object, our relationship to the software. Now, in software or in computers themselves, we can think of it as some sort of exchange between, let's say, software, hardware, peripherals, and humans. And somewhere we're bridging these entities so that they can interoperate with each other, that one of these can provide some information to another one of these and then get something back out of it. So on the most basic sense, on the left side, we have human to hardware interaction, right? Where we bang away on these little pieces of plastic that somehow send electrical signals. And then there is hardware to hardware interaction when we have the computer talking with, or the keyboard talking with the computer. Somehow all those little electrical signals make letters appear on my screen. Right? Hardware to hardware interactions can also be seen as, for example, a USB. A USB interface is essentially where I plug in my USB. So hardware to hardware. Hardware to software can be like the commands that you issue to control a robotic arm, for example, or a microscope in the case of BG's example, right? So there is something that allows us to kind of bridge between these different kind of entities so that a work can get done, that we can actually do something. So that's kind of the idea on the interface in general for computing. But when we're talking about application programming interface, we combine that together, we're talking about software that has an interface. And the software interface itself, when we say API, there's APIs everywhere. So just within the application software layer, we have games, Microsoft Office, Photoshop, calculator, browser. Between those different components, between the game and Microsoft Office, between Photoshop and the calculator, between browser and games, you can have interactions where we exchange data, input and output, where they somehow interact with each other. But there's also APIs between the layers of what we have here in this kind of an operating system diagram where the application software can talk to the system software. So when Photoshop needs to open a file, it's going to ask the operating system, find me this file. And the operating system will go and use its file system stuff and then somehow get all the bytes that constitute this file and feed it into Photoshop. Within the system software and the hardware, there's also an API where the system software, let's say your OS, is talking to your hardware, your memory, to figure out what do I do with all these bytes that I just pulled off the disk? How did I even get it on the disk? Does this operating system necessarily need to know, is it a 1994 hard disk that spins at 5400 RPM, or a 2020 hard disk that operates at 7200 RPM, and it's 5 platters now, so it's a 3 terabyte drive instead of the old. Operating system doesn't really care. It just needs to know overall size and some details about the way that's logically assembled on the disk. But there is an interface, right? Things like read-ahead caching and data integrity and anything that has hard disk corruption mitigation that it has. Operating system doesn't really need to know to do the job it does, for the most part. And so we have an API between the operating system and the hardware as well. But it goes deeper. Between each of the pieces of the hardware, there's also APIs. So if you take the system of the application where we're kind of are at our level, the application has an API to the operating system, but the operating system has an API when we want to create our application to maybe a compiler or a firmware, and the compiler itself will turn it into machine code. The machine code has something that will go into, well, I clipped off the instructions of architecture, but within the chip itself, within the actual Intel chip or ARM chip or any other chip maker, there's an API for the chip maker. Within the APIs of the chip maker for the instruction sets, there's also going to be APIs for the way that the chips themselves have been operating. For those who do a lot of work in security, things like dynamic allocation of memory so that it's more difficult for software to know where to find specific pieces of data, like passwords and whatnot. This random allocation of data is something that's done on the chip level. It's not done on the software level. But it is software on the chip, and there is an API for it. Basically, I just tell it what to write, and it tells me, or it writes it and tells me everything's okay. I ask it to read something. It goes out and finds it for me and reads it back to me okay. The fact that the chip doesn't, or the CPU doesn't necessarily know where it is in memory, right? The CPU just says, I want to write something to memory. But even within the CPU, there are places where the CPU itself will randomize its registers, also for security purposes and whatnot. So even within the CPU, there are packages that have been made into APIs for the CPUs themselves. And so it goes all the way to the circuit design. You can almost say that there are going to be logic chips within your actual motherboard that has software in it that your CPU has absolutely no idea about. Things that maybe control if there's a particular amount of heat that it'll slow down processing on this particular chip. CPU chip does the same thing, but so can other chips. If there are certain things that are plugged in that it'll route data one way versus another way. So APIs everywhere. In other words, whenever there's software and there's software that needs to talk to software and they're built by two different people or two different teams, and we have this idea of distributed software, there's probably an API that will glue them together. So far, so good? So APIs everywhere. Now, the APIs that we deal with as programmers are generally either on the language level or on the package level, where we have, interestingly, documentation that are actually called API documentation. For example, Node, when we're using Node, it's actually called an API doc. Early documentation for Java, they actually called it API documentation for Java if you wanted to see what you can do with Java. So here, as an example, is Node documentation, but the URL actually is API. Okay, kind of an homage maybe to that, or at least a continuation of that idea that you learning a language and the possibilities of all the methods of a language is also considered an API to the language. You don't necessarily have to know too many of the intricacies of the language. They just provide you all the tokens, all the keywords that you have to know to make a language useful to you. And then we have our package level or our service level APIs. I think Scott mentioned that they were using OpenWeather. That's an API, right? So how they collect all their weather data and do predictions, does it matter to you? Probably not. Do you want to do that job? Probably not. They do it 10 times better than you, maybe 100, maybe 1,000 times better than you. They do it consistently every day. And that's what they do, and that's what they want to do. And so why not let them do it and form some agreement between us and them as to how we want our data provided on a regular basis. All right. So I asked ChatGPT, what's an API? Yeah, that wasn't too bad. A set of protocols, standards, and tools. Maybe. Yeah, okay. To communicate and exchange information regardless of the programming language, operating system, or platform. That's pretty good. And then widely used in web development, mobile development, software development. So not a bad answer. Yeah. You would hope with the kind of information that ChatGPT is trained on that it would have a good idea of what an API is, right? Considering that it's trawling online information. ChatGPT also has an API. APIs everywhere. So ChatGPT's API, if you ever want to interact with it on a system-to-system level where you want to create a program that uses ChatGPT, there is an API for it. There happens to be one called text generation or text completion for ChatGPT. But of all the things that OpenAI makes available for you, like image generation, if you want to use essentially what is DALL-E, there's also that option. But OpenAI also has an API. APIs. Cool. All right. So APIs. Where do we even start getting this idea of the API? The way that we understand it now between software. I think it can be kind of maybe pointed to from the 60s. Mid 60s, we had this idea within distributed computing of a request response already. This is even before the web came to be. The request response idea was that, it's a pull response. I want something from you, so I'm gonna ask you for it. I'm gonna, you know, get it back from you. It's not so much someone trying to like tell me what they want or push information towards me. Rather, I have to request for the information to be given, and then they would provide the information back. And that was always there. There were changes through the time, and the most significant changes through all the times is that things become more standardized and a little bit more open, more language agnostic, more system agnostic. Remote, the request response was very specific to the platform and the language in which it was created. Thereafter, you have RPCs. RPCs are also rather language specific. Whether you consider remote method invocation as far as RPC is, debatable, but RMI just includes object in the RPC call. Afterwards, in the 1990s, we have ORBs, or object request brokers, or the biggest one being Corba, in terms of standardization of it. I won't bore you on the details because it was quite harrowing to try to do IDLs through Corba. 1998, we have XML RPC, basically RPC, but using XML as a common format between us and them. We'll look at XMLs in a second. And then XML RPC was renamed to SOAP. So simple object access protocol, better than Corba. A little bit more language agnostic. We still had to do marshalling, but the marshalling was done on a little bit more of a consistent and unified level because of XML. But also not great, as you can tell from Bij's response. Thereafter, we have REST. Now, the interesting about REST is that REST had been developed, or the beginnings of REST is actually probably early 90s, like 93, 94. There was the gentleman that was working on it. We'll get to him shortly. He didn't write the specification, or rather, it was actually a PhD dissertation. He didn't write that until 2000, but it did exist before then. It's just that it wasn't specified on a formal basis until 2000 when he finally finished his PhD. Oh, GraphQL, YAML, and all this. Well, yeah, that's another thing. Yeah. So representational state transfer. If we're gonna take it pretty literally. Now, REST, you'll find documentation. I don't call it documentation. So you'll find literature online everywhere as to saying REST is this, REST is that, REST includes all this and whatnot. So I'm gonna boil it down really finally and say that according to the original PhD paper, this is kind of what it boils down to. There's client-server communication, there's stateless communication, caching, uniform interface, layered system, and code on demand. Those are the things that he was kind of going for in terms of taking what was then the HTTP protocol and adding a proposed architecture using that protocol in a utopian world of data sharing. What would that look like? Client-server communication, I think that's kind of already baked into the name. There's a client, there's a server, they talk to each other. So there is a person who has the data that you need, and then you as a client can request the data. So kind of the request response mechanism. Stateless communication. The server doesn't need to know anything about the requester. So whether Robert asked me something or Andy asked me something, I don't care. Right? You, when you're coming to request something, have to bring in all the history with you if you want history. So if I saw you last week, to say, hey, remember you saw me last week and I had this and all that, I need all that information because as far as I know, as soon as you walk in, my mind's a blank slate. We're starting all over again. There's great side effects, or I won't say side effects, it has a specific meaning in programming, but there's great byproducts to having stateless communication. Efficiency being one of the largest, efficiency of performance. Caching to kind of address that efficiency and performance. Caching, mostly client-side caching. When you have a stateless environment, one thing that you can do and really take advantage of is caching. Okay, so we're not going to go too far into this. I can always see, I'm already losing some of you. So we're going to talk more about the uniform interface, which is probably the most important part of the specification. And of the uniform interface, the hypermedia as an engine of application state is the most prominent of those four that uniform interface breaks down to. Hate OAS or just hypermedia. But so what was the goals of the REST specification when it was created, or the PhD paper was created? To set or to provide a set of architectural constraints. And that's really all that REST is. REST is a specification. So you don't really create REST, you follow REST. Or what we call being, if you follow a lot of REST, we can consider you as RESTful. You might see that around. You might see some say that they're REST-ish, which means that they kind of follow REST to the most extent. Because remember, REST isn't just the web API protocols that we'll see in a minute. It's also all of these other things: client server, stateless, caching, layered system, code on demand is actually optional. But also everything that uniform interface provides. So as a specification, there's a lot more that is REST-ish than is necessarily RESTful. But that's okay, because we can still communicate with REST-ish. We can still do a lot of great work with REST-ish. Or REST-like, I've also heard. REST-able, I don't know. But to show that as a specification, you don't really need to have everything to be productive, but it is nice to have, because there's a lot of the stuff that was included in the specification was there for efficiency. Okay, here's an example of a REST. This one, we're going to kind of break this down a little bit more later on, but the get is the request, and the HTTP blah, 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 and everything below that is the response. And so we've created a request, received a response, and the thing to kind of take away from this, especially with the uniform interface idea, so identification of resources, manipulation, and self-descriptive messages. I'm not sure we get that in here because there's a header that's missing. But we have the ability to get data that we can act upon. And one of the things that REST also accounts for, which probably isn't going to be as meaningful to you guys on a normal basis, but the fact that I can include hyperlinks as a way to get more information is also one of the powers of REST. But I think what you'll mostly get out of this, as in terms of your interaction with REST, is the fact that there is a request that gets broken down with a resource method, or HTTP method, more specifically, which is the get. You have a resource, which uses a universal resource identifier, or a URL, universal resource locator. But this is more of, I think, an identifier, because this is a service rather than an actual item. But the URL here being accounts 12345, and the protocol HTTP 1.0. So there's a lot of stuff going on in that. And then stuff that's coming back, it's going to respond with the protocol and the OK, and then the body, or the payload of the response. Some of you will look at this and realize that there's, that you recognize this. It's kind of readable. So the uniform, the uniform interface part of it doesn't necessarily say that you have to use a human readable data payload, but it is kind of common. And so this format, some of you might already recognize, is called the JSON format. JSON, or JSON. Yeah. So the guy who created Douglas Crockford, just created this as a human and machine readable, versus ones before, especially with RPC and Corba, weren't necessarily human readable. They were actually byte arrays. They were, binary data. Not until XML did you get really good specifications of human readable. But the difference between this and XML is that it ends up being a lot more concise. You lose some stuff with XML specifications. There are specifications of XML that you could do to do type specification, which is lost in JSON. But I'm not sure we miss it all that much. We miss it kind of, but the explosion in growth of online services, I think, is mostly driven by the fact that it's much easier to use JSON than XML. XML is really wordy. So these two documents, XML document, JSON document, convey the same message. So those of you looking at the XML might be like, oh, it kind of looks like HTML. Well, it's a cousin to HTML, the ML and XML. They're both part of SGML, but they're kind of cousins to each other. So that whole tag idea is probably pretty recognizable. But JSON gets rid of all the tags and says, all right, let's just structure this, kind of like we do with the JSON object. Yeah, seems to work for the most part. And then, just as a side note, there's also another format called YAML in terms of a format, which is not used currently with REST APIs, but you can sometimes find it in other APIs. But it's also another human and machine readable format that is even more concise. We got rid of all the brackets. Now indentation matters. It's almost like the Python or Ruby of, of API formats. But anyways, so some standard request methods in HTTP. This is not necessarily RESTful, even though you'll see documentation online that consider this REST. The REST specification has absolutely no mention of any of the HTTP request methods, but you'll see them a lot. And so we're going to kind of go over them really quick. The only ones that we're going to concern ourselves with today are probably the get and the post. But there's also put and delete, which I would say are the second two popular ones, maybe even with options. The one that you don't see as much, connect, trace. There was one that was added in 2010, and then subsequently, I don't know if it was removed or they just didn't list it as a common use one. There was one called I don't remember what it was called now. Whatever. It was just to edit a portion of a Is it? Patch. There you go. Yeah. So sample size of 1. But yeah, it's not listed in the most recent specifications. It doesn't mean that it's not existing and it's not used. It's it just means these are the common ones that are being used. But yeah, there are. So in other words, there are others that are not on this list. It's not a comprehensive list. But you'll see some of these. And those method names, again, when we look back at the request example, this one uses the get. Oops, I forgot these are not text. This is an actual image. This one is a get HTTP method. Okay, so let's start programming. Yay! Now that I've killed your spirit. All right. So we're going to be using Node and Express, as obvious from today's title, as well as the slide. So hopefully you'll have been able to find, if you don't already, have Node, we don't need Express. Express we can download as after we download Node, but you do need to at least download or have Node installed on your computer in order to proceed. So you can go to this website, nodejs.org, and download the version for you. Who on here already has Node installed? I think that's the majority of you, but there's some of you that are still okay. So if you haven't already, please go ahead and install Node. One way to kind of tell whether or not you already have Node installed is to open up a terminal or a command line and just type in node ---- version. Yeah. Jeez. Now it's thinking about it. Now it's 18. Okay. So find a directory in which you want to start creating our stuff. I created one already for myself, I thought. Actually, no, I'm going to go in and create a new one. It's called CDU. And within here, typically, you don't have to do this. You don't have to use a package manager, but we're going to be using Express, so it kind of makes sense for us to do it. So I'm going to init, or npm init. And npm essentially is a Node package manager, which allows me to download packages. And so npm init will allow you to, well, it'll create the package manager file for, or the project file for you, which it uses to add in stuff. And so I'm going to go right. What's that? What's a package? Package is a external library of stuff written, in this case in JavaScript, for me to utilize. And it has an API for me to use as well. And so, for example, the one that we're going to use, Express, was written by someone else to expressly to help me create a application service, a web service. And I'm going to use npm to install it. But first, I need to create this thing called a package.json, and the npm init helps create it for me. I can manually create the package.json as well, but it's it's not too bad. It's not too much to type up. I can manually create this file as well, but the Node init just does it for me. Okay. So anyways, so after you run npm init, you should see a file called package.json in there. Those of you running a Mac, the command window is basically like a terminal. So if you have a terminal, go ahead and open up your terminal, and then try node space -- version and see if you get something that comes back without an error saying it doesn't exist.
Oh yeah, I have it.
So now go create a directory somewhere where you want to store all today's stuff. I think it might be easiest from within the terminal itself, since you do have to type in npm init. And to create a directory, you can do mkdir, which is pretty much a POSIX standard to create directories, and whatever you want to call it. Whatever you want to call it. And then change directory into there. Also a POSIX command, change directory to whatever you want. So you change directory. Basically, you're pulling yourself into that directory. So what I had done before is I did make dir new, and after make dir new, I did cd new to change directory into there. And that basically brings my current standing position into that folder. So all the future commands will be done in that folder. Okay, so at this point, we've created our package.json file, or told npm that we wanted to. Now we can have npm install a package for us. So we're going to install Express. Now, if you ever forget what to type in, you can always go to the documentation, which I always encourage people to do. And it'll also be on here as well. The only difference from theirs is that I don't use save because it's already implicitly, there since like 6 years ago. So just npm install Express is sufficient for now. Okay. Everybody good so far? If you type in enter, the Node package manager, or npm, will go out to all its known repositories of code, and it'll start pulling in Express. You can see that it told me that it added 57 packages. Everybody good so far? Okay, so 57 packages added, even though I only requested one, because Express also has a bunch of software that it relies on, and that software has software it relies on, and so on down what we call the dependency chain. There is an interesting visualization. Just for fun, we'll show you the visualization. So if we were to map out all the dependencies, and the reason why we download so much crap is because some packages rely on other packages, and down the dependency tree. And next thing we know, we've got 57 packages. Anyways, so it's a lot of stuff that we've downloaded, and this is one way to kind of get an idea of how big a package is that you download. The other way is to just kind of take a perusal. I don't know if I can do this. I guess so. So there's 59 directories because they included a bin directory and some others in a package.json, I guess. But here's also another way to kind of look at everything that I've downloaded. Express is among them, but they invited all his friends as well. All right. So we've got, and the other thing that npm had done is to update my package.json. You'll see that it included a new section down here called dependencies and added Express as a dependency. So this package.json will now try to keep track of the things that this project will depend on. Basically, it acts as a great way to try to reproduce the project in the future if necessary. But you know, that's another day of talking about stuff. So we're gonna keep on continuing. What did you get?
Nothing.
Oh, don't type in type unless you're running Windows. You can do cat or less or more or CAT. Yeah, we've bastardized that cat command over the years. It's originally intended to concatenate two files, but no one ever uses it that way anymore. Okay. Same. Yep. For those of you with VS Code, go ahead and open this library. I already have it. I don't even have it on this one, I guess. Some of you, especially those on Mac, or if you've installed it as part of the system, I installed it as a zip file because I hate installing stuff on Windows. So I don't have it as part of my path. I have to manually add it to my path. But for those of you who installed it normally, code as a command should work, and period meaning this folder. Or alternatively, you can just open up your VS Code and go there manually, which is probably what I'm going to do. File, open folder, find that folder that you created that you wanted to put everything in. I'm going to put it over here since it's easier for me to see from this corner. I put everything in projects. Put th. And right now I'm working in new, so I'm going to select that one. And then, so those are my package.json file that I had before. We're going to start creating files in here. So we're just going to create a very basic service. To do that, I'm going to create a new file. Create that. Click on that one, or Command N, Control N, whatever works for you. So So for me, Control N opens up a new untitled file. I'm going to save this file so that it knows what kind of file it is. So Control S or Command S, or go up to File and select Save File. I'm going to call this whatever you want to call it. I'll just call it APIs rock, for example, .js. That's writing JavaScript. And I'll zoom in a bit because this is really tiny. We're going to create our API server in here and using Express. So there's a couple of ways that you can approach this, but if you ever get lost, you can always go back to, this is not the one that I wanted, the Express documentation. In terms of getting started, it'll walk you through the most basic ways of creating a Express server. So they have one here. I'm going to basically type this out, so if you want to just copy paste to save time, you can. So, but what are we typing out? First, we're going to create a variable called Express, since I'm going to be using it to do more stuff. You know, call it whatever you want to call it. We're going to acquire the Express library. And then I'm going to create something called an app. And I'm going to use the Express constructor that was pulled out from the library. I'm going to create a port. Whatever port you want to use. I'm going to use 4.8. So good. We're going to create one endpoint. It's going to be a get endpoint. So, not a linked endpoint. That was weird. The get endpoint itself is going to respond to the route of /, which is root. And then I'm going to create a callback. But no, whether you want to do it with arrow functions, it's up to you. You can also just create regular function, regular anonymous function. In this regard, it doesn't really matter since we're not going to be doing anything with lexical scoping. It's kind of up to you. I'll just do, for this one, I'll just do regular functions since it might be more familiar to the majority of you. And then essentially, I just need to respond with something. I'm not going to do anything in particular. The API documentation shows that there's many different ways to respond. Ooh, there's that word again, API. There's different ones. The ones I downloaded, I believe, are version 4. I can always check by going to the package.json. Package.json says anything above 4, which then I would have to go into package lock to see. But I'm pretty sure it's going to be around 4. And this has all the versions of all the software I've downloaded if you want to confirm exactly when you downloaded. But I'm going to assume that it's 4. And then in my response object, you see that there are a lot of different things I can do with the response. The ones that we typically see used is the request.send, however, to end the response and send something back to the requester. But every now and then you'll see end or status. But we're just going to use send. So response send. I use res because in the parameters for my application get function, there are 2 parameters. This can also be found in the documentation if you look through. And I really want to encourage you guys to use the documentation whenever possible. So on the app.get, since that's what we're using, ooh, there's two of them. The first one. Okay, so app dot, and then there's the path or the route that I want to bind myself to, and then there's that callback. And then it tells me that the callback can be a series of different things. But what we're going to be doing is a function. And so here is the example, which is pretty much exactly what we had done so far. And so we're going to do a request send as well. So res send, and then whatever you want to send back. Yo, this is a great response. Okay, so we've set something in terms of a specification as to where I'm going to be listening, but I haven't actually started the server yet. And to start the server, I'm going to tell the server to start listening. So app.listen, server needs to know what port it's going to listen on, which I already specified as 888 as a variable. You could just put it in here as a literal as well if you wanted to save a line. Doesn't really matter. And then app.listen, let's go back to the documentation since I want you guys to do as much use of documentation as possible. You'll see app.listens. You need to specify a port, maybe a host, and a callback. If you specify a callback, and I kind of like to just because it allows me to see something. See if it says on here what that callback is. Identical to nodes HTTP server listen, blah, blah, blah. Let me see if it has it on here. Basically, it's a callback that gets called after the server has been created and listening has started. Yeah. Not well documented. Oh, that's set timeout. Okay. There, here, server listen. Server listening. Yeah, this one doesn't even have one. Okay. Anyway, if you provide a function at the end of this, this function is a callback, and it'll be called after the server gets up and running. And I like this because then I know that it didn't hang, that it actually started. Up on plus, for example. Whatever message you want for yourself, just to get some feedback from the command line that everything is a-okay, your server's up and running. Any questions so far? So far, so good? Okay. That's it. That's our server. So the top part is just a whole bunch of declarations, kind of like get stuff out of the way, get their names kind of set as to what we mean when we use these names. But the important thing is 5 through 7, where we actually specify an endpoint. If traffic comes in here, this is what I'm going to do. This is my behavior, how I'm going to respond, and what I'm going to do. And then the 9 through 10, which is, hey, start the server. Get rid of that since we don't need to see that. I'm going to try to put this on the left side and everything else on the right side so that you guys can catch up in typing if I ever get too far ahead. Huh? Oh, that's right. Push to the left. Down to the right. And for this one, okay, once you get that up, go back to your command line or your terminal. If you've closed it, you need to go back to that folder that you're working in that has all the files that you just created. CD, API, tab, API, tab. I don't know what you do. Enter. Do an ls really quick to verify we're where we're supposed to be. Okay. And then just for now, type in node and the name of the file that you just created. For example, APIs rock.js. And then hit enter. And your computer is probably much faster than mine, but after it gets up and running, it should spit back out the message that you specified saying that everything's A-OK, we're running. Okay. So now that it's up and running, we can verify by opening up our browser, going to localhost, which is my computer, whatever port you specified, and you should get a response from the server. 5,000, so there's quite a bit of room. You'll see a lot of tutorials generally stay within the 8,000 range. That's just a convention. It's not required to be that way. I think it kind of builds upon the fact that 80 is typically used for HTTP traffic. And it's like 8080 is really easy to type. And so 8080 is usually the default go-to for a lot of tutorials or test servers. And then from there, all the permutations like 8088, 8888, 8, bunch of 8s, right? But there's nothing necessarily special about the 8,000s range. There is something special about the 80, and there's something special about a lot of numbers under 1,000. But anyway, report numbers. Everybody good so far? All right. And so we got a server running. Now, one thing I can do is, now when I'm sending this response, I'm actually sending HTML. Well, I'm sending text. But as far as the browser is concerned, this can be HTML. You can kind of prove that to yourself by putting in H tags. I'm going to save it, go back and restart my server. So Control-C to kill it. Start it back up. Go back to here. Hey, now it's an H1. Now, this is not really how we're going to be using this long term, because we're probably going to be using our APIs just to pass in data, like raw data, not necessarily HTML. But it's possible. You know, as far as the browser is concerned, it's just going there, fetching something, bringing it back, and then if it happens to be HTML, because that's the kind of request I added when I went directly against the API point, then it's happy. Probably won't be doing that from the client side. Client side will probably have something running in the background that kind of gets the data from the stuff in the background. HTML has already been rendered, and you're just going to be supplementing the existing HTML, the existing DOM tree with the data that you've just retrieved. Any questions so far? Nope. Okay. So now the question is, what do you want to build? We have the platform. What should we build? Motorbang? You want to make Facebook, huh? How much time you got? Yeah, but then they were like, the language is so bad, we're going to make our own version of it. What about a pets API? A what? Pets API. A pets API. Okay, describe to me what a pets API does. You get a list of pets. A list of pets. Okay. Okay. Do I have to type out this list, or is there one that exists on the internet? We're going to make an API that accesses an API. Oh, meta. So I think OpenAPI always uses the pets store as an example. So I figured they have some pet store API out there. We can make a short Swagger pet store. Yeah. Ooh. And that's the one. That's the one. Okay, so this is an API specification itself, but not the data. I just need the data. Oh, well then just query together. Is it just going to get me the?
No, not just a get what, dude.
Yeah, we're gonna have
Is there anything in that useful link, the pet store repository?
Yeah.
Is there any data in there?
pet store.
If you scroll up, like the
Oh.
pet store
Ah.
repository. There you
The repo itself. The code.
go. Palm XML, is this some Java stuff? Oh, it's Java, baby.
Yeah. In the main resources probably. Nope. Just a YAML.
Get endpoint for this is like our own, like very simple data. So, you're saying there's a get endpoint for inventory. You have to go back to the Swagger. No, it's the previous stuff. Or not, here, yeah, that's right. So if you scroll down to store inventory. Oh.
Inventory.
Oh, never mind. Can we just make our own, like, really simple little baby data structure? Yeah, why not?
I think.
Fancy dollars.
I want to say I've seen it before though. JSON sample JSON data pets. There you go. JSON example pets data.json.
There we go. Nice. Okay. Yeah, perfect.
What? And copy all contents. I'll put the URL in the Discord channel. Oh, I only got 3? Yeah, whatever. It's more than 0.
Yeah, it's a lot. I believe they only serve at the beginning.
Okay. I'm going to take this file and we can do one of two things. We can make an external file or we can. Really? Or we can put it as a just a raw string. But I think having it as an external file makes it easier. So I'm going to go back to my editor, Control N, which doesn't work for me because VI stuff. Get rid of the VI, try Control N again, still doesn't want to work, so I'll do Alt F and new file. And then paste it into oh, I didn't copy it all. Maybe. And I'll save this as pets.json. Okay. Now, like I said, there's a couple ways that we can use this. We can read this in as an object itself because it is a JSON object notation. One of the advantages of working in JavaScript is that JSON is based off of JavaScript, so it's basically how objects in JavaScript are created. So it is in itself an object. I don't think I have to export it as a module. Hopefully, we'll see. The other thing that we could do is you can pull it in, read it in as a string with the file system and parse it that way. But let's try, let's just try requiring it. Let's try pulling it in as an object, as an entire thing in and of itself. So I'm going to put that in a separate site down here. I'll say pets require, and then from the present working directory, or dot, pets.json, you'll see it tries to autofill for me. And then for now, I just want to send all the names. So instead of res.send that way, let's do res.send. And apologies for the gibberish this might end up being. Pet.name. Okay. Instead of, you know what, each, I'm going to do a map. Oh, too much Ruby lately. Map, and then after I do all the mapping, I'm just going to join them as a string with comments between them.
If you check the JSON file, there's an initial property called pets as well. So you
okay. As a root. You are right. There is a property.pets, which is the array that we want. All right, I can do that. Pets list. So, pet list, and then for each pet list dot pets dot map, since that's the array. I'm going to pull just the names as an array out there, and then I join them by all commas, so it turns them into a string. So I should just get a string delimited list of all the names. To make it a little bit more readable, I will put this on separate lines. And then from here, just to make sure that we got all okay, I'm going to restart my server. Now, sorry, I'm going to restart my server this way. I'll show you a different way to start the server now that we're constantly restarting. And it's going to be not so fun. Okay, so we got a list of names. So at this point, we've probably restarted our server a couple times. I'm going to show you an alternate method to do this. Huh?
Using the watch option inside the system.
Words?
Watch.
Oh, watch. No, I'm going to do something a little different. I'm sure this might actually work with a watch as well. But typically what I'll do is I'll run npx. And the difference between npx and npm is that npx will download the software but won't include it in my package. It won't be part of like the thing that's required to run my stuff. I'm going to run npx. I'm going to pull down and run a package called nodemon or node monitor, which is just going to do a watch. It's going to watch my code. If any changes are made, it restarts by itself. So then that kind of eliminates the start-restart cycle. Yeah, it's going to download and it's going to download nodemon, but it's not going to install it as part of your package, not as part of your project. It's just going to download it for the sake of only running it. And then so anytime I make changes into my software, so I'll, for example, add a space at the end and I save, it says restarting just changes and it starts up automatically for me. So that less control C up enter thing, a little bit easier. What? Light server? Live server? It should. because the live server is just a browser. Yeah. Whereas this is actually restarting on your server. Like maybe I'll add a space between on and the port number, and then I save, and then it sees that change and restarts the server for me automatically. So it's kind of a nice like maintenance thing it does for me. Yeah, so we have something that returns a list of pets. Now, returning a list of pets, not too bad. I'm not sure what we're going to do with it, but not too bad. But really what we kind of want to return is if we want to, follow what typically you see under REST APIs, most REST APIs that you'll see online, including like OpenWeather and whatnot, the interchange or the data interchange format or the format that is provided by the server and spit out is usually JSON. And so instead of just sending a comma delimited list like we do here, let's see if we can augment that or at least change that so that it's JSON instead of what we have now. So how do you guys want to do this? There's lots of different ways to do it. I'm going to propose that I am just going to take the map, and with the map, but the map itself is going to return an array, so that's not exactly what I want. But instead of mapping, maybe we'll do, what is it that we want to return? Do we want to return an object that is an array of names? Do we want to return a bunch of cats with a property name? Okay.
Can we, like the REST API would, for some given ID, for some index of the array, return that item from the array?
Sure. So that's a different endpoint then.
Yes.
Okay. Let's finish the all endpoint, and then we'll do the specialized endpoint that we can actually specify or give it data in addition to getting data. So in the getting the data, I think, what I kind of want to get out of this is maybe something similar to what the pets JSON is going. Now, I could just toss the pets back at the user, but let's be a little bit more selective. Yeah. So the pets itself, it looks like it's an object with an array with an object that has names. The idea of passing back an array of objects with the property name, okay, I think we can do that. So that means that for everything that is in the array itself, as for each pet, we're going to return something that has a name. But we can't, okay, we'll get to that in a second. So we have a property called name, and the name itself is set to pet name. We can't just leave it like this because these curly braces actually mean something special in a anonymous arrow function. So instead, I'm going to use a parenthesis around it, and that'll pacify its need. And then this will get me a bunch of arrays with an object with a name in it. And then if I want the pets on top of it, then I'm going to have to give this a property. So I'm going to send back then the property called pet, which is in an object. But I don't want to send the object itself because it can't send back and forth objects. So instead, I'm going to do a JSON stringify. For you. Okay, let's try it.
It does, sure.
Okay. A lot of like fancy stuff going on in the background. But if we wanted to be a little bit more literal, you could also add in the JSON stringify as well. But since it already does it for me, I will ignore it. But there is some magic happening in the background. It's taking my object and converting it to a string. Let's keep that in mind. If some of this code starts getting a little oblique or weird to parse in your mind, just let me know. There are more readable ways to do this. I'm just doing it this way because it's fast to type. But if you would rather sacrifice fast to type for better readable code, let me know and we can switch modes. stuff that's going on. Now, another thing that we'll want to do is try to do what Beach had suggested, where we can provide it a little bit more data to be more specific about the behavior of the endpoints. More specifically, if I provide it an index number, it's going to get that index number from the data store. In this case, it's just a JSON file, but it could have been the database. It could have been, many number of things. It's going to get that particular ID and return it. And so let's do that. For this one, we'll probably also, let's for now at least, use another get endpoint, and then we'll try a post endpoint later. But this get endpoint is going to be a slash, and let's give it a little bit more than just a slash, and let's say maybe give it a pet and an ID. The colon is significant. It tells Express that this is a variable, that it's going to actually do something special, essentially take this and assign it to a variable called ID, whatever exists after that slash. And then after that, everything else is the same. Again, for brevity, we're going to use arrow functions, but you don't have to.
Our pets don't have IDs in our JSON.
Nope. Yeah, this is going to end up being an index number. No.
No.
We can, I guess. I don't know how robust you want to make this, but it's more for concept, I think. But yeah, well, why not? Since you suggested it, we'll do it. So we have an ID. Now we have a pet list, and we have a pet list that has a pet. You know what? The only object in pet list is pet. Or the only property is in there. And so to kind of streamline my code a little bit more, I'm going to have it only get the pets. And that's going to become my pet list. That way I don't have to specify. Just because it's the only property there anyway. Right? So I don't have to keep on saying pets, dot pet, dot pet, dot pet. Just to verify everything still works, I didn't break anything, restarted, everything looks good. So on the get pet ID, then I already have an array list that I have, and I guess I could, if you want to really do checking. First we can see if the ID has been set. I think they'll get a 500 maybe, if it's not already set anyway. That's something weird. And maybe also check the length. If ID and ID, this comes in as a string, but since we're going to be using comparisons, maybe I'll do an implicit cast. Kind of not great, but that's what JavaScript does. Is less than pet list length -1. Since indexes start at 0, then we'll do a res.send and pretty much do similar to what we had before. We're going to send an object, and this one, the object itself will just be, you know what, we don't even need to wrap that in an object, so I'm going to take that out. We're going to send pet list sub whatever the ID. Yeah, because the length will give me starts with counting with 1, and my ID start counting at 0. Oh, that's a good point. But no, I do not.
You need to extract the ID from the request.
Oh, requested ID. Thank you.
Yeah, does this work? What you actually use, like as in the documentation, like request rec.params.
Oh, .params?
Yeah,
that could be it too. It's been a while.
It's
Say again? Oh, I changed the scoping of that, so I don't have to keep typing pet list.pet.
on the second line.
Yeah. But since I did it so often, maybe I'll just create a local variable.
You also probably want person.
Technically, yeah. JavaScript, eh.
Well, the array access. It is?
Oh.
Wait, why is it not?
So let's say let ID equals request.params that ID. So that simplifies a bit of the typing.
So I think
And then let's see if that works. Oh, cannot get.
yeah, URL is head specific.
Oops. Yeah. That's eagle eye. How do you see that from the back? With gray text. Seriously. And there's my JavaScript object.
So JavaScript, well, the string is numeric, does it automatically typecast it to when you're comparing against a number? Yeah.
It's a property. Because remember, you can use a square for object properties as well. It's an object. The square isn't necessarily to show that it's an array technically, it's to show that it's an object. So in that object, you're looking for a property called 1. And it happens to be a number. So it's okay. Yeah, it's interesting. So don't think of it as like a map or anything like that. Should probably. What else can we send? Maybe error.
And then, make sure that ID exists. If it does, make sure that it's less than the length of your
Would it be nice to like return a different status code as well?
Like a 404 or 400 something.
404 maybe better.
Yeah. I think. Let's look at the. Do you happen to know off the top of your head if one of the responses allow me to add in a.
You can change the call like the status and you invoke the status method and then use dot and
Okay, so I can change it. I can chain the send and the status and the send. Okay.
He's not returning.
So
Server receives the request and it's just like, yeah, I got a request, whatever. What we should be doing is, as an else, basically return an error. And status statue.
Stop statue. Okay, so let's try that. Well, we'll find out. That's part of the workshop. Try stuff out. Back over here. Go back over there. Open up my inspector. Show that at the bottom. And then something else. Hit not found. Where's the network? No. Do it again. Where's my 404?
Now, normally you would want your API to be consistent, so you return JSON for your other endpoints. This should also be a JSON. So you probably want to convert it to a JSON. So you can do something. Just this is
Yeah, what?
error.
This one? Oh, once you open up your inspector, you should have network. If you don't already see it there, you can always click on the carrots to find it. If it's too short, it'll clip it out. But once you then make sure that all is selected or fetch is selected, one to one, but all is typically fine. And then refresh. Okay. So we've also added an error condition with the status of 404. For those of you who might have missed it, but don't have to use 404 somewhere in the 400s. The 400s generally meaning something's missing. Yeah. 404 is a general not found kind of thing, but I've also seen 403s and you create your own in the 400 series and people get the idea.
Isn't there like a 418 or something like on the teapot?
Oh, I don't know if it's 418, but yes, there is one that's on the teapot. But
Yeah, 418 on the teapot.
Nice. Because why not, right?
Oh shit, I have to check that out second.
That you're a teapot. So the 400s, we have bad request, unauthorized, payment required, forbidden, not found, which is what we used. We manually put this in, so this is not automatic. So you as a programmer kind of try to find the most appropriate response. Not allowed, not acceptable, proxy, request timeout, conflict, gone, which typically means the server or the API server behind it is gone. Too long, unsupported media type, and then 418 on the teapot.
Dude, I want to make an IoT teapot.
Right. But it's a brewing teapot, like an electronic brewing teapot, not a fire teapot. So it can return the 418, right?
Yeah. I want to make an actual valid 418 teapot.
Okay. Where else should we go with this? Maybe we should create a form that has all the names on it, and you choose one of the names, and then it displays all the information about that name. Sure. Yeah, let's do it. Yeah. In my mind. Now we're gonna run into CORS issues. So one way I'm gonna get around that is to just have everything run within the same server. To do that, I need to specify. Why does it keep changing this? Specify a static folder for it to use. So the static folder, which is basically stuff that the routes are not going to somehow cover. We'll create one called public. Call it whatever you want. Static, public, blah, blah, blah. And then within my file structure, I'm going to create a folder called public. And then within that public folder, I'll create my little pets.html. Pets.html, you can use Emmet. Don't have to use Emmet. You can just put in whatever you want in here. You don't even need the whole HTML stuff to make the HTML work. But just for now, to make sure everything works, is I'm not a teapot. I'm just gonna put this in here to make sure everything looks okay and works okay. Back in my exclamation point and a blank file that has the type. You gotta make sure that your type itself is HTML. So either save it as an HTML file or select the language mode in the bottom right.
Yeah.
Okay. And then to make sure everything works okay, I'm just gonna duplicate this one because I'm gonna use it too. what did I call this?
You don't need that.
My pets. Okay. I'm not a teapot. So my statics work.
This one's for like responsiveness. You know, mobile. So you can reach scale.
Okay. So now my server knows how to deal with static files as well, which is good for us now to deal with cores with conflicting server port numbers, which are considered two different services in terms of cores. So anything that I put in the public folder, if it can resolve it, it'll use it. So good so far? So far so good? So this is my HTML file that I'm going to use to create my little drop down, and my drop down is going to include the names of my pets. And so let's create a drop down. I think that drop downs are typically created with selects. Maybe I'll give the select an ID. The ID will be pet names maybe. And typically it contains options, but for now I'm going to leave it blank because I'm going to have it dynamically created with JavaScript. So in dynamically creating with JavaScript, essentially I want to create an AJAX request. There's a couple ways to do it. We can use.
This will understand exactly.
Sure. So yeah, we're going to be creating then an XHR request. So I'll just call this XHR for lack of originality. XML HTTP request. No. Then you got to learn promises and everything. But anyways, how do I use this? I don't remember. Students, you should be able to tell me how to use this.
What does he need to type? There's 4 steps. What does he need first? What's step 1? Well, he already created step 1, right? But he needs
Okay. Is there anything in there?
not necessarily.
Okay. So no options, just regular. And then what? Huh?
What's step 2?
Okay. To where?
2 arguments. That's the first.
What's that? Get. Okay. And then? Okay. And for us, we're not going to go for the JSON. We're going to try using the API that we just created. So what's the address that I'm going to use? What address would I use? No, not the JSON. What API? Where is it? Which of these is at my API endpoint? Well, here, I'll make it easier because it's not actually on the screen. Where's my API endpoint? Huh? Here? Here? In general, here? Somewhere on here? Okay. The API endpoint I'm going to use is just a slash. Right. It's just the root. Right. And so that's it, just a slash. And then anything else?
Are we done with it?
I don't know, are we? This is the root we're using. Because first I need to get just a list of stuff, then list of names to populate my select list. Okay, so I got the open, now what? We can fix it. Null? Node? Send null? Send a request? But we're not telling it what to do with the data before we send the request. We just send the request and it's like stuff comes back and we just like, let's throw it away. Oh, we do? Okay.
I always make them do send first.
Alright.
Because so many times they type so much stuff in the event listener that they forget send.
Alright.
I tell them to go back up.
Yeah, it's a little out of order, but whatever, it works. So now what?
Well, we type it below, and then I tell them to go back up for step 4.
What's that? So add event listener accepts. What am I typing? Huh? You tell me what you want. On state change? Oops. Console log. Alright. That's fine. That's fair. But the function itself has got to, I get something, right? Oh, I see what you mean. Okay, we're going to pull it out of the body. Okay, so, and then what? Kevin, do you remember? From 3 months ago? 4 months ago? Maybe even longer? 7 months ago? XHR? What? Oh, you're going to actually just type out the ready state. Okay. And then what? If what? Ready state. What are you going to do with this?
Then after this, you're gonna target the what you want.
So let's console log this. I don't really care about the ready state as much. Whatever, we'll keep it there. But it's, since we're doing a couple console logs, we'll put a little bit more context around it. Oops. So that's the state, and we'll say XML response. So let's see what I get. I'm going to open up my console so I can see my stuff. And refresh the page. And, oh, I got state 2, 3, and 4, and then XML response is null. Now, to make sure I'm hitting my endpoint, one thing that I could do is to go back to my API itself, and in here, I can console log get list or something like that, just so I know that stuff is happening. I can even put a date time on this one, but I'm not going to. So they get a little bit too much. So I'll do the request again, get my same response, but now, oh, it's still starting. Oh, there it is. So I know that it hit the endpoint. So I've confirmed that it hit the endpoint. Well, like their XML response is no. What happened? What happened?
You always, if you go back to, you don't have to change that. Yeah, so let's go back to your index.js. Yeah. And now we got to create an event listener for that. I'm actually going to bring this up.
So instead of using XML, because we're not passing XML, you can just use response text. The public folder. Am I what? Yes. Oh no. I'm accessing using the server to get to it. Right. So I have specified a static folder for Express to use. Yep. And so my browser is just going to localhost/mypets.html. Express knows that this file is not an endpoint, that it's an actual file that needs to serve. Okay. So the only change I made to catch you guys up is instead of using response XML, I use response text. Okay. And the response text I get back is the names under this thing called pets, which I'm not sure I want it that way. But then I don't know how many people I'll lose if I change it, because it doesn't seem like people are working on different things at the moment. So I will leave it alone. Instead, I will parse it the way I need to parse it within the HTML. Okay. So create a response object. So that is JSON.parse the XHR response text to take that text and turn it into an object.
So you need to create a new
And then the thing that I'm interested in is the response object. Inside the response object, I'm interested in a thing called pets. And then for each of the pets, we'll call this pet. I'll just call it pet. Well, a couple ways we can do this. The long way or the short way?
So what happens is the server is looking
Yeah, we'll do it this way.
and whatever's in there is going to serve it.
Options of
I don't know if I want to make it a name, but we need to have this become a number. But this is not great because there's no numbers matched up that I can do searches on. So let's just use name.
Right? The server serves out whatever you tell it. The server is looking to a whole There's a static file there. And whenever static files are in public, it's going to serve directly. Right? We haven't said, hey, serve the public file.
Objects,
Just
so
say serve those files.
selected index, stop that. Well, this is what you should be doing. That, no, that's okay.
Create text node. Do I put it? Can I put it in the constructor or not? I don't remember.
So this one is select dot option, the server select dot selected index, and then the end dot value.
Yeah.
Okay, put it right in there. There's something in the public folder.
Just a
Oh no, I can't.
So we should do this one maybe.
Oh, I can't.
So that's let me change that. Yeah, you don't have to try that same. So yeah, so now we got a some parts. Should say some parts. I don't know. I'm going to stay with you for now. I'm just going to pump a lot of data, see if I'm getting it.
Everybody caught up? No? People are still typing? Does it make sense what's happening? Somewhat, maybe, maybe not. Some stuff, yes. Okay. So if the ready state is done, which is 3, I can actually comment that out. Or 4 rather. I can comment this one out as well. Get rid of that one. So I'm going to take that text, which is just JSON text. I'm going to convert it into an object using the JSON parser. So that takes the text and converts it into an object that I can use. And then I'm going to take that object and look inside the pets property of that object, which is an array. And then for each element of that array, I'm going to create options, set all the proper things for the options, like the value and the text for the option, and then I'm going to add it to the tree inside pet names. And pet names is my select, so it's going to add it to my select.
Is your typo intentional?
Which one?
Repson sauce?
Repson sauce?
Repson sauce on line 19 and 20.
Oh.
I mean, you did it twice.
Yeah!
Repson sauce.
That's how you know it's done on purpose. No, it's not. Yeah, I use autocomplete a lot. But yeah, it should be a response object or rep object or whatever you want to call it.
You did it again!
It's response object. I gotta type it out.
So then he does a for each, going through each item in that list.
Okay.
And then
For now,
I'm going to get back to create a new
now let's see.
The creating of the inner HTML, you have to be careful when you're doing the append, but no. One of the biggest gotchas for inner HTML is if you have, for example, event listeners, because the inner HTML replaces, just blows away all the old HTML. If you have event listeners attached to some of those elements that used to be part of the old HTML, those event listeners are now attached to nothing, right? Yeah, and so it's more concise, and I like to use inner HTML. But just know that caveat. We're not using event listeners on this one, so we could have just used inner HTML. Inner HTML replaces. Create text node, yeah. Create text node we could have just done with inner HTML. Instead of create text node, I could have done new option dot inner HTML equals.
But then if there's anything already inside there, appending the child will just add whatever is inside of that HTML tag.
As long as it's just a node, it'll append the nodes.
So basically, from one, you need 24 instead of 7.
Okay.
So hopefully some of this is familiar to you guys in the intensive. Creating an element, setting the value of the element, which is an attribute, and then setting the text inside the element, which, as John and I were discussing, could have also been done with just inner HTML, but since we went down this route of manually creating objects, we continue manually creating objects, creating this text node that also contains the name. So that is the text between the tags, right? That's the option close tag name, and then open tag close option, so on, end option. Okay, so we have something. All right. Maybe just for the sake of what I have, I'll create an initial one that just has choose one. And the value of this one will be none. And then for the sake of time, I'm just going to blast forward. So we have an option listener that will get. Did I not save? I didn't save. Choose one, and then has all the things on it, which means that this needs an event listener for listening for events on it. So I'm just going to kind of blast forward really quick, but we'll see. Pet names needs an event listener. The event listener is on select, I believe, and that is a function that is probably going to at least have an event. And the event itself, does it have a selected? I don't know. It's been such a long time. Select event. And let's see what happens. There, and then I choose pers a lot. And the onSelect doesn't like it. OnSelect. Is onSelect the wrong event? 1 second. No, onSelect is the correct event. Right? But does it pass nothing? I thought it passed the event itself. Maybe not. Yeah, it's not triggered for me either. Hold on a second. Nothing. OnSelect's not.
Looks like it might be on change.
On change?
Yeah, looks like it's on change.
Okay. Okay, that works. And then pet names dot. Does it give me a selected value? Let's find out. Oh, selected index. I think let's go with Kevin's really quick. Value. That might be right.
Yeah.
There you go. Very good. And so that way we can get the value. So then we're going to have to re-hit the backend. And so we're going to redo all the same thing that we did before. That XHR equals new XHML request, HTTP request, XHR dot open, and where this is going to be another GET request, and the endpoint is /pet/ and the name, which was pet names dot value, and then we're going to have to change our endpoint to take, instead of indexes, actual names, but we'll get to that in a second. Then you guys said you like to do the send first, that's fine. XHR dot on ready state change, and the ready state change itself, do we have anything in there? I don't think so, it's a blank function. And that itself is a function where we're going to check to see if XHR, we said that ready state equals XHR done, and if it does, then we're going to get the stuff that's going to come back, which is the response text, and we're going to JSONify it. So I'm going to say then let rest equals JSON.parse the XHR response text, and that's probably going to come back with an object, and that object itself I can use to decipher into some other elements, and so that would be document dot. Let's not create elements anymore. Let's just add stuff. And so I'm going to actually go back to my HTML and add on something underneath select as a div to for all my results. Pet result. And then leave that as is. And then so pet result dot inner HTML equals, and then we're going to add in our stuff, and that stuff being a what? I don't know if I want to format any of this stuff. Yeah, why not? Sweet. This one is going to be a res.name as a div, and then div as a res. I forgot what else is in the object. So let's go back to the JSON file. Species, favorite foods, and birth year. Oh, and there's a photo.
Yeah.
Oh, nice. Okay. So we'll start with the photo. Image source equals, and that is going to be pulled from the res.photo. I think it was called photo, right? Yeah, it's called photo. And then res. What was the other one? Diet?
Food, but
Oh,
only the cats
species and favorite food.
have, yeah, but the dog doesn't have food.
Oh, it doesn't? Okay. So we'll just say res.species. And the last one being birth year, I guess, since one of them doesn't have favorite foods. Birth year. It's all lowercase, right? No, uppercase. Y. We can actually do favorite foods as well. Res dot favorite food. What? Favorite foods. Fab Foods.
Wait,
Is it capital F? Yes. Let's see whether or not it's defined. If it is defined, then we will do the res.fabfoods dot join the comma space. If there is none, we'll just say none. And then I guess I can add a little bit of titlage to it. Okay. So far, so good.
Why did you close those divs?
Which divs?
The Google divs.
Because I forgot. Well, thank you for catching it. You're learning. All right. And then for my APIs, Rock, I'll keep that up for people to catch up if they're so inclined, though I need some room to do stuff, so I'm going to zoom out. For this one, the ID is coming in not as a number, but as the actual name of the pet itself. And so I need to change this logic here, since it's no longer an ID but a name. And so instead, I am just going to filter through them. So what is this thing? It's called pet list. Because I'm sending the name. So let me see. So pet list filter send. Of
the response.
It's not guaranteed to be in order. Jason.
But it's an array. An array is
So front end to back end, would I be able to? Yeah, I guess I would be able to guarantee order. Okay.
I don't have to rewrite any back.
Good point. Let's do that then. So in that case, yeah, the value is going to have to be on this for each. I can do a for. I think it does. Let me see if there is a for each.
You can get it in. You have to pass it in optional argument like.
It's a second parameter?
Yeah. You have to add that.
Okay.
With parentheses.
Yep. Right. So then the new option value then should equal 5. And then the on change, we can get the pet names value and send that as an okay. That's good. So let's see if that works. So we choose one, say barks a lot, and just whoa, that is huge.
I did not.
So let's do a bit of a styling where images are bound for width to 200 pixels. No way, man. You figure it out. I'm kidding. All right. So I just added just one thing to limit the size of these images. But so yeah. So now we got barks a lot and meows a lot and so on. Catnip and celery. All right. A fat one.
I saw a video on Reddit of a cat just going off on a turnip. Or like a beat. No, it was a beat.
You know what? I'll open it again on this side so you can see it. Two sides. Get a little bit more vision. sweet, delicious dirt.
I don't know what beet derived. I don't know.
It's usually sweet. If you get red beets, they're sweet.
Yeah, I'm talking about red beet.
All right. We kind of flew to the end there, but what you got?
He just likes my bouncing marquee.
Oh yeah, nice. So you added some style into yours. Nice. Okay, so we have an HTML file that uses the API that we have. Unfortunately, we didn't get to post, which would have kind of fun to add stuff to it, but hopefully you get the idea, at least what's going on in terms of setting up a server, creating the endpoints, and then using JSON as an exchange format. In an hour.
Does this mean we're full stack developers?
Yeah, you all get certificates. Any questions? No questions? Can you take a picture? For documentation purposes? Okay. So while he's setting up the picture, I'm going to load up the last couple slides.
Everyone say cheese, say
Queso. All right, so to close out tonight, one thing I want to point out, some people wonder are APIs copyrightable, and this was a case that was actually recently settled by the Supreme Court in the U.S. So I'm not sure if it applies, globally, but typically a lot of countries follow the U.S. and the consensus was APIs are not copyrightable, not because of the limitations of copyright law as it pertains to APIs, but because of fair use. And so that was pretty recent. That was in 2020. It's a pretty big case. It was big ramifications as to the future of APIs and its use. And the last thing I did is I asked ChatGPT to give me a poem about APIs, and it gave me a very, very abstract poem.
Is it rhyming haze and ease?
Yeah. Has.
He's
Ease.
no clouds.
He's and ease.
What accent is that?
The ease.
Ease.
Navigate with ease.
Clarity, disparity.
I wonder what poet style.
Oh, I asked it to write it in the style of the Tao of programming.
Oh, okay.
But I don't think it really, other than just being really abstract about like sun and clarity and skies and stuff like that. But yeah, that's it. So hope you enjoyed. Afterwards, we typically go out and have chicken and beer together. It's a free dinner for those of you guys who want to join, and it's a great opportunity to meet others in the group because we do want to predominantly become more of a social group. So we do encourage you guys to come and hang out with us, and hopefully you'll see you again next week. I have a couple ideas for the event next week. Not really sure exactly what it's going to be just yet. So watch Meetup to see what pops up. We also have events on Saturdays in Gangnam. So if you have time, come hang out with us on Saturdays in Gangnam. Thank you very much.
Thank you, Alex.